Okay, I'm going to give you two more examples to show how mixed operations works with complex fractions for rational expressions. Here's two examples. In the first case, the thing that makes this a little bit different is that these terms here, the one in the numerator and denominator, don't have denominators. So it's really just a 1. So the LCD here is x plus 3. That's what I'm going to multiply onto the numerator terms here, and this one onto the denominator terms here. Now I'm going to skip a little bit of work. X plus 3 times x, that's x squared and 3x. When I multiply this rational expression here by the x plus 3, I have a numerator factor, denominator factor that are both binomials and equal. So they're going to cancel, just leaving the 2. Denominator, x plus 3 binomial, times x minus 5 binomial. So we're going to FOIL that. First, the outer is 3x, inner minus 5x. Let's put that together. And the last, there you go, there's that product. You can pause if you want to show more work and verify what I did. Again, here's a rational expression, denominator x plus 3 binomial. Here's an x plus 3 binomial to multiply on the numerator. Those will divide out and cancel, leaving just the 12. So I have x squared plus 3x plus 2 over x squared minus 2x minus 3. Now, we cannot cancel these x squareds, they're not common factors. But there may be an additional factor. Let's see if we can factor this into two binomials. Product of 2, sum of 3. That would be 2 and 1. On the denominator, x and x. Product of negative 3, sum of negative 2. That would be negative 3 and positive 1. Notice that I have two binomials that I can divide out that are in common, and I'm left with the simplified x plus 2 over x minus 3. That's my final simplified answer. Alright, let's have a look at this one over here. Now, before I get going too far on this one, I'm going to recognize a difference of squares here, a difference of squares here. I'm going to want to factor those. Also, this trinomial and this trinomial both factor as well. So let's look for any common factors there. Likely to be written with a common factor, so be suspecting that. Denominator here will form two binomials. That looks like x plus 3 and x minus 2. Notice I have the x minus 2 in common. I'm going to take advantage of that factoring that I just did and write x plus 3, x minus 2 here. And that difference of squares already got factored. X plus 2, x minus 2. So hopefully it's clear to you that the LCD is x plus 2, x minus 2, and x plus 3. I have three factors that I multiply on the numerator and on the denominator. This is the method that I prefer to use. Okay, so when I multiply on this rational expression, these two factors are going to cancel with those two, leaving only x times the x plus 3. In this one, these two will cancel, leaving only the x plus 2. You may want to pause and just study what I did there and make sure that makes sense to you. Denominator, these three binomials multiply, and they will cancel with two of these, leaving just the 2x numerator and an x plus 2 factor. I write the minus x numerator. And these two will cancel with these two by division, leaving just the x plus 3. Alright, I'm going to expand. I've got x squared plus 3x. Distribute that negative sign. Minus 2x squared minus 4x. Denominator. 2x squared and 4x. Distribute that negative sign. Minus x squared minus 3x. Let's gather my terms. X squared minus 2x squared, negative x squared. 3x minus 4x minus x. 2x squared minus x squared, 4x minus 3x, plus x. I can go further. I'm going to factor a negative x from the numerator, leaving a remainder of x plus 1. I'm going to factor the x from the denominator, leaving a remainder of x plus 1. These are common binomial factors. The x factors are in common as well, and so the only thing left was the negative, a negative 1. There's a couple of examples. You may want to go back and just replay them and pause it at certain points to look at what I did along the way.